Hi everyone, Eric here. I'm a mechanical and solar engineer in the state of Florida. I graduated from University of Florida several years ago with a specialization in solar energy and utilization of solar energy. I formed a company in 2008 called IRE Solar, or International Renewable Energy. Our main focus is solar hot water, installing solar panels as you can see in these two pictures. This is a recent installation that I've done with my company in 2014, this year. I also install solar electric panels, also known as solar PV or solar photovoltaic, and those are the electricity producing panels. This presentation is about solar hot water, which is using the sun's energy to heat cold water or heat water to make it hotter. And in this presentation I talk about a specific type of solar hot water technology called solar evacuated tube. It's kind of a newer technology here in the United States, especially in Florida. You'll see it a lot more in northern states and a lot of other countries, such as Germany, France, England. This is a really popular design that's used in the northern climates. A couple reasons why that is, and I'll go over that in this presentation. One of them being lower wind loads. The wind can go in between the tubes that you see, and also that the snow can fall in between the panels. So I'll go into details about this. So again, solar hot water, these are not electricity producing panels. So the panels that you see on this picture right now, what's happening is the tubes are made out of copper. And there's usually a gas, freon, or just air on the inside of these tubes, or sometimes a liquid, depending on the manufacturer and the type of evacuated tube or solar hot water panel. And the sun will heat those tubes up, and you see the metal bar at the top. It's black. Okay, that metal bar heats up. The water flows from left to right, or right to left, however way the installer sets it up. And basically the tubes help heat that hot water up using the sun. And this is an extremely efficient system. Very efficient. It's actually more efficient number-wise than using solar electric panels to heat hot water. Now, one of the things that shocks most people is that hot water is usually the first or the second largest part of the electric bill. When we're selling solar hot water systems, or when I'm talking with my sales agents for my companies that I deal with selling hot water systems, basically we tell them, hey, the hot water is most of the time, 90% of the time, the second largest part of the electric bill. And why is that? Most people have electric water heaters standard in their house, and it takes a lot of electricity to heat water, to heat 1 gallon of water. So when you take an electric bill, when we do an analysis of a customer's electric bill, whether they're residential and they own their own home, or we go to a commercial facility, say like a factory, and we look at their hot water tank, usually 20 to 33%, about 1/3 of that bill is usually hot water for residential, especially. So what does solar hot water do? You purchase, or you can lease, a solar hot water system, get that installed. We pull all the permits with your area having jurisdiction, AHJ. Basically what that means is that we install a solar hot water system properly. We pull all the permits, do all the engineering, make sure that won't blow off the top of your house, make sure everything's legally done. We have the city or county or building inspector come take a look at it. And once it's hooked up to your hot water tank, over time, over the next few years, that system should save you 20 to 33%. Why? Because the hot water from that solar system is extremely efficient, and it can keep up with that electric backup or the previous electric hot water tank. So what we do is we usually take someone's electric bill, looking at the last point, and we multiply that by 30% or 0.3, same thing, and that usually tells us a very good estimate, a roundabout estimate that tells us how much a solar hot water system will save you. Now, another question that I often get is, how does this work? So on the right side here, you'll see a diagram that shows the solar collector with the tank, the hot water tank, and you also see the system of how this is set up. And in this system, This is called a independent solar thermal system. And what this means is that you can see that looking at the red, the hot water basically comes into cold into the solar hot water panel, okay? And then moving down, the hot water goes into a heat exchanger inside the tank. So this is again a special type of tank that we'll install and that's included with this package. And basically it heats up the already existing water inside your hot water tank. And this picture here also has the backup, like say a boiler or an instant hot or your other electric or natural gas water heater. We can hook that up to the system too for backup, just in case it's cloudy for like a week straight or we don't get a lot of sun. But even still, the solar collector should keep up with heating up your hot water tank. This picture also has a controller, and what that controller does is it controls the pump. There's oftentimes a pump, and that pump can actually be solar powered as well. For most installs that I do, we don't have the ability to put a PV panel there, but in case of say a residential customer that wants everything off grid, we can definitely put a PV panel that powers that pump. And that what that controller does is it measures. You'll see the dotted line actually on the lower right of that controller that goes to the hot water tank. And what that does is it sees that, say that hot water tank drops to below 80 degrees or 90 degrees Fahrenheit. The customer can actually set that on the controller. The pump will turn on and pump that cold water up to that solar collector. The sun will heat that up and it'll drain back down or move down with the flow and heat up that tank. So usually it's still at night, and the controller has a temperature differential device inside of it that determines when it turns on and also when it's nighttime. So we definitely can do different types of systems depending on what type of tank, whether you are on natural gas, on electric, how many solar collectors you have, how many controllers. I've done installations where we've had to do 12 or more solar collectors in different parts of the building to go to different tanks, like say for an apartment complex. So that gets a little more, no pun intended, but complex when you start factoring in the different solar collectors, the different controllers, the different tanks. There's equations that are needed to be calculated based on the pipe runs, how long the pipe is going to be with the hot water. So we also insulate everything so that we can minimize heat loss. On the left side of this slide, we basically have information about the basic sizing guidelines. We want to install that solar collector so it's perpendicular with the sun's rays as much as possible. In Florida, we typically install anywhere from 20 to 30 degrees, somewhere in that range, or we try to make it as flat as possible with the roof. Now, solar thermal is, again, extremely efficient, and as more and more people find out about it, the market is increasing for solar hot water every single year. This graph, unfortunately, only goes up to 2008. This is the best data that I could find, is up to 2008. But basically, we have different types of solar thermal water heating and solar hot water heating. It's usually divided into solar thermal for your home, solar thermal for your commercial, and then solar thermal for power plant generation. So this slide has nothing to do, or this presentation, excuse me, has nothing to do with concentrated solar power, CSP, and what that means is those are the types of power plants that are usually in Arizona, Southern California, New Mexico, where they reflect solar light using mirrors on a large tower, and that usually has, say, high temperature salt, a molten salt for instance, and they use that for power plant production. I have another presentation on that on my YouTube channel, and feel free to watch that. What this talks about is low temperature solar water heating and medium temperature. So some people actually use solar thermal panels or specially designed solar hot water panels for space heating. Very popular in Germany and up in the northern climates. I've actually seen quite a few systems like this where they'll have piping, copper piping, or a new type of piping called PEX, which is a high temperature plastic tubing, and they'll run the hot water through this PEX to heat the floor. or heat a driveway and melt the snow. It's very fascinating, very energy efficient, very neat that people can do that, and engineers have made those systems, and those are definitely widely available. Now, the return on investment is the #1 selling point of solar hot water panels. When you look at your electric bill and you see that, hey, it's 30% of what you're paying is really going to the solar hot water. It's like 20 to 33% is going to the solar hot water. Well, when you purchase or lease, and then install a solar hot water system, okay, that savings is immediate. The day that turns on, the second that turns on, basically we have hot water flowing that's powered literally by the sun that goes into your hot water tank. So looking at the typical price of a solar hot water system, you're looking at anywhere from $3,000 all the way to higher end $7,000 for a solar hot water system. I'll go into a little more detail later in the presentation, but you get a 30% federal tax credit in the United States and its territories. Yeah, so you have 30% off the bat, and if you're a business customer, you can depreciate that over a period of 6 to 7 years. So it'll fully pay for itself in anywhere from 3 to 6 years is typically what we tell customers. We have seen in cases where we've installed it for $3,000 to $4,000 for a family of, say, 4 to 5 with, say, teenagers. We know that children or teenagers or young adults typically take longer showers with hot water. Households with more children are more active. You're running the dishwasher more. You're running hot water for the laundry a lot more. That solar system will save you even more money. And then the ROI, return on investment, can be less than 3 years in that case. So basically looking at that and knowing the fact too that I've seen solar hot water systems that have been installed in the 1960s, been operating for 40, 50 years or more. We recently drove by in Gainesville, Florida, a little town in North Florida. We saw a solar thermal panel that had been installed in 1982, 1983, and it was going strong. Nothing wrong with it. The homeowner just had to cut a tree that was basically planted at the time of the installation, and now it's a huge, huge oak tree, water oak tree. But basically, they have to constantly cut it down. So that's the only negative that they found about solar thermal. Otherwise, they love it. They go up every once in a while, just clean the panel every few years with Windex. Other than that, the pump still works, the panel still works, and it's still saving them money with their hot water tank. In this slide, I'm actually showing you two different pictures of a solar hot water panel. On the left-hand side is a picture of a flat plate collector. It's one solid piece of glass. There's actually two collectors in that picture mounted on the type of roofing that's common in South Florida, particularly in Miami, Broward counties, Fort Lauderdale area, and Naples. We've done some installs there. That's actually a difficult type of roof to install because we have to remove all the tiles. But regardless, the one on the left is called a flat plate collector. The picture on the right is the evacuated tube. So two very different technologies, but when you look at it, they operate in almost the same way. They both use copper, and they both have water flowing through them, whereas the evacuated tube on the right-hand side of the picture has the water flowing through the top of it, again, the bar. And you remember on my first slide, my very first picture, I had these same evacuated tube collectors. Now, the ones on the left and the ones on the right, both the flat plate and evacuated tube, they're roughly the same price. Sometimes you get evacuated tube for a little bit cheaper. The evacuated tube, I think, is much easier to install. Whereas you look at the flat plate, that's one solid collector, and that can weigh 200, 300 pounds, depending on the size, how much copper, how efficient, and again, it's a little more difficult, so it takes a heavier lift and a crew of at least 2 to 3 to get a flat plate collector up there. Whereas the evacuated tube, you notice there's individual tubes. I have a YouTube video on my YouTube channel where it shows me putting in the tubes, and you can see some of the tubes missing. So you can bring up these lightweight tubes that are 1 pound to 2 pounds a piece, less than that probably. and you just screw those in. So the evacuated tube on the right hand side, that installation goes much quicker. It is much easier. It's a lot less roof penetration, whereas you look on the left and that flat plate collector, you have to remove all those tiles, whereas on the right hand side, that's a different type of roof though. That looks like a shingle roof that I took a picture of. But you notice on the right that the shingles will still exist underneath the panel. So it's a lot less roof penetration, which is good. It helps prevent leaks too. But the one on the left, the flat plate collector, that's obviously sealed in as well. So that's not a problem at all. So it won't leak. And also that the efficiency is roughly the same when you look at it. The evacuated tube, however, in colder weather and in snow, will actually perform slightly better. The reason being is that the snow slips between the tubes, and there's a lower chance of wind shear or wind ripping off an evacuated tube. And the reason being, the wind can move in between the spaces and between the tubes. So that's a definite advantage of evacuated tube. So again, I'm a big fan of evacuated tube, but if I had to pick between the two, in terms of efficiency or product, it really doesn't matter. They're both extremely efficient. Again, the flat plate collectors have been around for over 75 years. So the flat plate collector is a proven technology. And again, that example earlier where I said, hey, there was a flat plate collector installed in Gainesville, Florida. That flat plate collector that was installed in 1981, 1982 is still there. So flat plate collector, definitely a good technology, and definitely is proven with weather and in time. It's just that in northern climates, you'll have a good chance where the snow will stay on the solar flat plate and not fall off until it heats up, so you could lose some production in that capacity. Whereas the evacuated tube, it's rounded, so everything just kind of falls right off, and it's again a much different technology. Here's another another picture of what a flat plate collector installation looks like. I actually like this picture better. I should have used this one earlier. This shows you a cutaway of a flat plate collector. You'll notice the glass, the metal absorbing plate, and the copper tubing inside. I also have a YouTube video on my channel that I show how I built a solar thermal collector just like this, with the fins and the copper tubing. So it's basically this is a big version of that. You have the pump, you have an expansion valve, expansion valve and tank and a vent, and that's basically if something freezes or if something overheats by accident or whatnot, you have safety devices inside the circuit so that either the water vents out, the heat vents out, so no one will get hurt. And also they have the pump. It shows the controller, and it also shows the hot water tank that's typically, for most customers, that's inside their garage, inside the shed connected to the house, or in the basement. So what we do is we have to figure out where we're mounting that solar hot water panel, and also how long the copper run is going to be. How much copper? Are we going to go 20 feet? Are we going to go 10 feet? Are we going to go 100 feet? Now, when we start getting beyond 50 feet, we have to make sure that there's enough heat and that the solar thermal panel has a powerful enough motor to move that water, and also that everything is heavily insulated, because we want to minimize the heat loss through that copper piping. And again, copper piping is very expensive nowadays. I can run, as of November 2014, copper piping is more than $5-6 every few feet, when you buy it in bulk, several hundred feet at a time. Whereas you go to Home Depot or something like that, it could be $25 for a 10-foot piece, I believe is the latest prices. I'll have to double check on that. So one of the things that we do, and looking from an installer perspective, is we want to minimize the copper run that goes to that hot water tank. The more we minimize that, the more efficient the panel is, the more hot water that will arrive, and also it'll be a cheaper install. Typically, the $7,000 install that I said was for 2 solar hot water panels, and we had to go almost 55 feet. So that was why that particular install was over $7,000. Now, this picture I would probably say is probably the most accurate of what a solar hot water installation would look like. Now, if we could replace that flat plate collector with the evacuated tube, it would look exactly the same. The copper, the orientation of the copper piping on the top would be slightly different, just because the two connections on a evacuated tube are right at the top. You have water flowing basically perpendicular with the tubes. And also, we might have a heat dissipator device. And what that is that's just a radiator, just in case the evacuated tube overheats. See, a solar flat plate collector, as you see in this picture, really can only heat water up to about 120 to 150 degrees. I haven't seen, I'm thinking in Florida, I have not seen a solar hot water panel like this really go over 150 degrees by itself on a normal day in North Florida, especially with the vents, especially with the controller, circulator, with how much hot water it's producing. It really doesn't go over 150 degrees. On average, 120 to 130 degrees Fahrenheit is the highest. Whereas an evacuated tube can actually create boiling water if you're not careful. So basically what we have to do with an evacuated tube is put a heat dissipator on that if we have a short run, for instance. Alright, this slide is frequently asked questions about evacuated tube collectors. I don't like reading off of it, so I'm going to just kind of summarize for you. The technology is about 20 years old. It was developed in Germany by Daimler-Benz Aerospace. So again, it's not a new technology, but it's not an old technology like flat plate collector. So an evacuated tube, it's still been around. There's some installs that I saw in, say, China or Germany that were maybe 10, 15 years old. They were installed in 1999, 2000, 2001. Now, the sizing of the system really depends on how many people are in the building or how many people are in the home. For instance, in most installations, thinking about it in Florida, North Florida, where I've installed the most solar hot water, is the evacuated tube size will be anywhere from 4 to 8 tubes, or anywhere from 8 to 16 tubes for a little larger family. And then for commercial, like some of the recent YouTube videos I have on my channel, I'm using 32 tubes, and those are for large apartment complexes that are using a single hot water tank. Now, also a frequently asked question I get is, will these tubes break? And the answer is no. The tubes are manufactured and they take a fairly large BB, and it's a 35 millimeter metal ball, and they shoot it at the tubes at a very high velocity to make sure that they don't break. And honestly, we've been pretty rough with some of the extra tubes that we have just to see if we could break them, and it's very, very, very difficult to crack the glass. The specialized glass copper tubing on the evacuated tubes. So that's not a big concern about evacuated tube. And we also, when we install a system, we actually give the customer a couple extra tubes, typically anywhere from 2 to 3 extra tubes. And again, the life of the tube, I have here 15 years, but we've told many clients probably 20 years is what it's going to be, is how long it's going to last. And over those 20 years, you've probably seen your return on investment at least 3 to 4 times in that time. Okay, and the last slide of my presentation, I'm showing you some pictures of a recent solar hot water installation that I've done. This is called a drain back system. There's different types of evacuated tube and flat plate collector design variants depending on the situation, and this system was done at a commercial facility outside Jacksonville. And this is an evacuated tube system. The picture on the upper left and the upper right are 3 different collectors actually. They're very close to each other though. And you can see on the top we have some of the copper piping installed, and we're actually missing some of the tubes. We haven't screwed in all of the tubes. I actually have a video where we have an installer screwing in the tubes for a few minutes, and that can be done in about 30 minutes or less. We can screw in all the tubes, and you can again see the minimal roof penetrations that have been done with an evacuated tube system. Lower right hand corner is someone actually installing with the lift in Florida. Has some umbrellas because it gets pretty hot in Florida. But you use the lift and we can install the panels very easily. And you can imagine we would need a larger lift if we had flat plate collectors, because it's one solid gigantic piece that is 300 pounds or more. Whereas these flat plate, these evacuated tube collectors were relatively easy to install. The middle bottom picture is a drain back tank. Basically, the system that you see with the evacuated tubes is an independent system. The water and fluid that's in these tubes, or that flows through these tubes that's heated up, is not actually going into the hot water tank for the residents of this apartment building. It's actually going into these tanks. We have about 7, 8 of these tanks, and these are called drain back tanks. So when it's cold out or freezing out, for instance, the fluid that's inside, usually like say a glycol, drains back into this tank. So this is about 5 to 10 gallons. I believe this was a 10-gallon tank actually. And then we have a heat exchanger on the inside of this, so it's basically a heat exchanger with the actual hot water tank. So the fluid that's in these evacuated tubes can get extremely, extremely hot, and it can be a glycol solution. And in this instance, I believe it was just water. But in this case, it doesn't actually influence not influence, but doesn't make direct contact with the actual hot water tank. And in this case, there were several 200-gallon hot water tanks at this installation, and the system has worked fairly well. And in the lower left-hand picture is a picture of me on the job site installing these panels. Alright, well, I hope that you enjoyed this solar hot water presentation and you learned a few facts about it and you're more comfortable with solar hot water. Feel free to message me or leave any comments if you have any questions, and I can definitely answer them. Again, thank you for watching.